So, hello friends. So, till the previous video, we have seen that what is the importance of phase margin, and we have seen the higher order transfer function. What was our omega p1, omega p2, and what should be the value of omega p2 and omega z for this second order transfer function with respect to the omega UGB. And above that, we have seen what we have seen. Let me wait here. So yeah. So very first, we have seen this ideal structure where we have considered there is a no output impedance for the GM cell and this transfer function was coming out to be GM by CLS. For it, the UGB was like GM by CL, and we have seen the 3D frequency was zero with the infinite gain. Okay, so in the second case, so when there is a R out was considered for the GM cell, then we have seen the transfer function was such that we have a finite DC gain, which is GM by G naught, which is a GM R naught as well. So what is 3D frequency is nothing but G naught by CL, and what is this? What we call the UGB frequency is again the GM by CL. But there is some possibility of 0 and omega p2 which is coming from inside the structure of GM cell that we will see on the transistor level also. So this is the second order transfer function. Rather, this omega p2 and omega z are at a much higher frequency, but they can come closer as well. So we will see their calculation exactly, and we will analyze the circuit in terms of the phase margin. Okay. So now let I take these phase margin for each and every these three scenarios. Okay, so let me take the first scenario first. So what was my first case? Yeah, my first case is H of S is GM by CLS. So what I can say, the phase margin is what? If I write the phase first, the phase is here, which I also call the angle of H of omega, which is always minus 90 degree because this is nothing but it can be written as like, if I write it as like a H of omega, it is Gm by CLS or CL of J omega, I should say. And if I write the magnitude here, H of omega, magnitude is what? Gm by CL omega. And what is the angle? Angle we can see because J is on the denominator, so always it is a minus 90. So from here, what we can see, phase margin is nothing but 180 plus 5, which is nothing but plus 90 degree, which is very good phase margin. Because it is ideal case, so it is very good, which is not actually expected, or which is actually expected, but we cannot achieve it. Okay, because no structure is ideal, no current source is ideal current source in practical world. So, or I can say no GM cell is ideal GM cell. Okay, so what is the second case? Second case was my DC gain was GM by G naught, and my 3 dB frequency was G naught by CL. Okay, so from here, if I write what is the phase or H angle of H of G omega was minus, sorry, not 90, yeah, minus his contribution to the pole minus 10 inverse. What do you see from here? We can see, okay, so it is coming as minus omega by, or I will say better to say R naught CL. Okay, yeah, better to say this. So what we want, we actually want phase at omega equal to omega UGB. Okay, so what it will be? It will be minus 10 inverse. What is the omega UGB? Omega UGB is GM by CL, and what is your R naught CL? Something is I think incorrectly written here. Okay, sorry. It is omega naught CL by G naught. Not omega naught, it is a omega in general, and we want at omega equal to omega UGB. Okay, so omega CL by G naught. Okay, so from here, what you see, okay, I should erase this also. I should erase this also. Yeah. So what I can write, I can write it omega UG. What is omega UGB? Omega GM by CL, and what is CL by G naught? So what you can see from here, minus tan inverse GM by G naught, which is nothing but minus tan inverse DC gain. Okay. So actually the DC gain is high value. Usually the GM by G naught is higher value. So I can say it is nearly minus 90 degree. Okay. So still this system is not a problem. If DC gain is enough high enough, then we can say my phase margin is nearly plus 90. So it is a good value, which we can say from here it's very good actually. It is not a 90 throughout, but in this case it was a 90 throughout. It was minus angle was minus 90 throughout. So at UGB somewhere here, or I will say, yeah, at omega UGB also it was minus 90 because it was on minus 90 throughout. But in the practical case, it is not throughout minus 90. But if we consider GM by G naught to be high, okay, if we consider GM and G naught, this is a DC gain to be high, then I can say if it is very greater than 1, then I can say this is nearly contributing to the minus 90, which is a phase margin nearly coming to the plus 90, which is again a very good value. Now let's consider the higher order system. Okay, so I want to write the phase here. What is a phase? Which I also call angle of h of j omega. It is what? It is coming as plus tan inverse omega y omega g minus tan inverse omega y omega p1 minus tan inverse omega y omega p2. Okay, so these all things I want that omega equal to omega UGB. So now let I take few approximations, which is one expected value that omega UGB is much higher than the first pole, which I call the dominant pole. And second approximation that I want omega UGB is equal to omega P2 let for time being, and I also want omega UGB equal to omega Z. These are two approximations for time being. These are two approximation for the timing, but this is a more practical thing. We always design for this. So what will happen in that case? This 5 will come out as plus tan inverse 1 minus tan inverse nearly a large value, or I should say DC gain, which we have seen on previous page, minus tan inverse, this is also 1 because we have considered omega p2 is omega UGB. So what is this? It is plus 45 degree minus it is nearly 90 minus 90 degree, and it is minus 45 degree, so it is cancelled. It is coming as minus 90 degree, which is giving me the phase margin of plus 90 degree. Okay, so what positive we are seeing here, when your omega g and omega p2 are at least the omega UGB, they are cancelling each other because they are on the same point. This is the one thing. And as we can see from this approximation, that my system is exactly the first order system. What is happening after or at the UGB. Okay, before UGB, my system is first order, so it is exactly matching the ideal case. That's why there is no problem. After that, it is also omega UGB. After UGB also, it is like a first order because there is a pole zero cancellation happening here, because I've considered that omega p2 equal to omega UGB and omega z is also equal to omega UGB, which I consider just a case. So they are cancelling each other. So what I'm saying, if my system has a first order response, if my system has a first order response till UGB is very good. Even if the approximation is not till the UGB, then what other thing that we can see, at least my system response should be first order systems around the first order response around this UGB. Till the UGB is first order is a very good thing. It will give me exactly the ideal response, which is a 90 degree phase margin, 90 degree phase margin. But if it is not happening, then other case, if some approximation, which will not I talk in detail, if something is happening like this, let's say this is my first pole, now this is the second pole, and somehow if I put some zero here and my UGB is coming here, so what I can see, this was my first pole, this was my second pole, and somewhere intentionally my zero was coming here. So this is P2, this is P1. It is just an example. Don't take it as of now serious, because it will take again a depth discussion. So this is my omega UGB. So around omega UGB, what I can see, this slope is minus 20 dB per decade. Means it is a first order behavior around the omega UGB. So this thing is also this thing is also acceptable for better phase margin. So for good phase margin, it is acceptable. I can say this thing. But now, if my omega P and omega G are less than this omega UGB, then what will exactly happen there? It is a left hand side zero, that's why it is cancelling the effect of the pole. But if it is a right hand side zero, it will also add the effect to the pole. That you will see. Okay. So what other case? What was my phi? My phi was plus tan inverse omega g. Sorry, it was omega by omega g minus tan inverse omega by omega p1 minus tan inverse omega by omega p2, and these all thing I want at omega equal to omega ugb. Okay. Yes. So let me say omega g is zero point 0.1 times omega ugb, and omega p2 is equal to 10 times of omega ugb. Means it is thrown outside, it is thrown outside, and it is pulled inside this ugb. These all are like hypothetical discussion, because actually for the single stage op amp or the single GM cell, the omega G and omega P2 itself has a relation that we'll see when we'll go in the transistor level. But just I am doing some mathematics, then we want to see what is the phase margin coming for these two approximations. Okay, it is not an exact thing, so it is a hypothetical analysis, just to get the idea of phase margin. That's it. Because from a single GM cell, from single GM cell, because from the single GM cell, omega P2 and omega Z also has some relation. So they are not that independent. I am taking the values, some relation. Okay, so they are not as independent as I am taking the value, but it is just a hypothetical for calculation purpose. Okay, so what is the phase? Just see it fast. Tan inverse, it is a zero point 0.1 minus, I will directly say 90 degree, minus tan inverse of 10. So it is approximate, I can to the very low value of nearly, let's say, 5 degrees, and I can approximate it to nearly 90, let's say minus 85 degrees, sorry, 85 degrees, let's say for a time being. So what the value is coming actually, minus 85 and minus 85, it is coming as uh, I am correct. Am I correct? Okay, so I think I have done thing in the opposite way. Instead of writing in the positive way, I have written the another way. So actually, what should happen here? It should be opposite. So yeah, it will be around 10 and it will be 0.1. Okay, so I can approximate it to, let's say, plus 85 degree, and I can say it is a very small, zero point 0.1 of 10 means nearly I can say 0.5 degrees. So what is happening here? Here it is happening 85 degree minus 95 degree. So it is coming as minus, what I'll say, minus 10 degrees. What is your phase margin? Phase margin is 170 degree. So what happened actually here? Actually, what was happening here? Our slope is nearly reaching the minus 180. So what is happening actually? It is not a perfect assumption, but there was a pole, then there was zero, then after UGB there is a some pole. So it is something like that, some sort of this. So I think it is not a correct way of approximation. Just the mathematics I was trying, so you can see this thing and how we can relate this. Okay, so yeah, if opposite thing happens there, if my omega g is, let's say, 10 times of omega UGB, omega P2 is, let's say, zero point 0.1 times of omega UGB. In that case, we can see it is what? Plus tan inverse omega G by omega UGB is, sorry, omega UGB by omega G is what? This is now 0.5, and it is nearly minus 1090 degree, and minus tan inverse it is coming in 10. So what is happening here? Let's say this is nearly 0 means 5 degrees. I can take, and it I can take minus 85 degree for the time being. So what it will be? It will be minus 85 degree minus 85 degree. So it is coming as minus 170 degree. So phase margin is coming what? 180 plus 5. It is at UGB. Okay. So what is happening? Plus 10 degree. Poor. Okay. So previously was not a correct approximation because there means zero is coming there, and this zero is staying for a long time, and after the second pole is coming after a much higher frequency. So some sort of, it will not exactly happen like this. I'll say better to say it will be something like this. Some pole was there, then some sort of zero came, then again pole came. So it was something like that. Okay, so ideally it should be the UGB, but now the UGB is thrown here. Okay, so this was some sort of case this that we have considered here. Yeah, so what we can see, then this is the effect of the zeros. Now let you have the right hand side zero. Now we have right hand side zero. So right hand side zero itself is contribute like a pole. So it contributes like a pole to the phase margin. What means to say? Let's say my transfer function is something like a naught 1 minus sy omega z 1 plus sy omega p1 1 plus sy omega p2. Okay, so here what we will see, if we will calculate the phi, then 0 itself will give me the negative phase. Okay, and all are the negative phase, so 0 is also contributing to the phase margin in negative sense. Okay, so even if I consider that my 0 is at omega UGB and my omega P2 is also at omega UGB, which the case we considered first, and previously they were cancelling each other and the phase margin were coming 90, but here they are not cancelling. Actually, they are contributing both to minus 45. It was already minus 90, so it is also contributing to minus 45. Overall phase we are getting is minus 80 degree. So what the phase margin is coming? So phase margin is coming as 180 plus this phase which is nothing but 0 degree poorest, I would say poorest. Okay. So what effect actually we are seeing? We are seeing that the negative side pole is affecting your phase margin very negatively. It is affecting your phase margin very negatively. Okay. So even it is not exactly contributing to minus 45, even if it is not contributing exactly to the minus 45, or it is even contributing to minus 5, then also it is adding some negative phase. They already are negative. This is already minus 90, so it is giving me some negative phase. Okay, which is not desirable thing. Actually, what we wanted, we want that this zero should compensate this phase angle. Instead of adding some negative phase, it should add some positive phase. Then this is already 90, and the second is already, this is my pole 2. Okay, so this is 90 because this is always holding, because minimum we consider that omega UGB is much higher than this omega 3 dB. Is a pole 1, which is nothing but the ratio is called omega UGB by omega p1, which is nothing but a dc gain. So this term is always 90, so not a problem. But these two should cancel such that we should have the better phase margin. So omega z minus omega p2, sorry, not omega, phi p2 minus 90 degree. So for getting the better phase margin, let I want the phase margin of yeah, let I want the phase margin of minimum 60 degree. And what should I do? If the phase margin 50 degree, 60 degree, and what is the definition of phase margin? Definition of phase margin is 180 plus phi at UGB. So what I will say, it is 180 plus phi at UGB is what? Phi g minus phi p2 minus 90 is equal to 60 degree. So what it is coming? It is coming as 90 plus phi z minus phi p2 equal to what I should say, yeah, 60 degree. So what we can see from here, yeah, we can see from here, okay, 90 is fine. The phi z minus phi p2 should equal to minus 30 degree. Okay, so it should be minus 30 degree. So for that, if I am considering the case, it should be minus 30. If this is contributing to like phi p2 is 20 degree, then it should be like what? Minus 10 degree is acceptable. So that is a minus 30 degree. Okay, so if it itself is contributing to 30 degree, then it should be to 0 degree. It is acceptable. So this difference should be of what I say. What is 5p2 exactly? What is 5p2 is what? Uh, 10 inverse omega by omega p2. And what is my 5g? 5g is tan inverse omega by omega g. So sign are already adjusted. Okay. So if this value is 20, means it should be minus 10. And is it possible to maintain? No. So if it is a 30 degree, it should be 0. Okay. So depending on this, how we get the minus 30 is we can see. If this is like 40 degree, I'm getting from here, then I'll get 10 degree from here. Okay. So this will be like that. If this omega g is also the negative value, so what will be there? Then minus 5g, sorry, minus 5g and 5p2 equal to minus 30 degree in the case of 60 degree phase margin. Then what should be there is 5g plus 5p2 equal to plus 30 degree. Now you can see what is the combination for that. So we can see either, okay, so in that case, what should be exactly there? If yeah, 5p2 is what? Omega UG by p2. So in that sense, omega p means omega p2 and omega g should be such that they are contributing to 30 degree only. So even if they are equal, so let me explain this concept. Okay, the relation phi g minus phi p2 equal to minus 30 degree. This relation I am getting for phase margin of 60 degree. Okay, when my 0 is left hand side 0. When my 0 is left hand side 0. Second case, minus phi g minus sorry, minus 5 P2 equal to minus 30 degree. Same for the 30 degree phase margin. 5G plus 5P2 equal to 30 degree. Okay, so I know that 5G is our tan inverse omega UGB. At omega UGB I want to see. And one more thing, sign are already adjusted, so this value are exactly the magnitude values. So what you can see, what is the possibility here? Let even I consider they are equal, then what will happen? If omega GB equal to omega G, what will happen? It will also be 45 and it will also be 45. Then there is 0. So this thing I want more and this thing I want less. Yes, if this thing I want less, then what I can say, it will be less than 45 means this omega UGB should less than or yeah, it should less than omega Z. Then we will get a less. And for this to get higher, omega UGB should means greater than omega P2. Okay, so if omega P2 even coming before this omega UGB, then we can have this condition. But for that, a particular relation will be there that we can see. And now what is happening here? Okay, if I want means this thing, let I am giving the omega G to be 15 degree and omega P2 to be another 15 degree. And what you say that omega UGB by omega G should be less than what I should say 1 and omega UGB by omega P2 should be less than 1 as well. Okay, so these are few things you can see this calculation what is happening here. So my point here to make is that if your right hand side 0 is there, it is contributing negatively to the phase margin. If sorry, right hand side 0, and if the left hand side 0 is, it will anyway cancel the effect of your pole. Okay, so once the effect of pole and 0 are cancelled completely, then we can say we have the better phase margin, which is nearly 90. Here we can see it is nearly 90 when they are cancelled. Okay, so this thing I should tell you that I told once look at this particular thing, that what should be the exact relation for that, and what more analysis you can do here, you can see. Okay, so this is enough for I think frequency analysis of 5 transistor OTA on the level of means some sort of control sources, then after exactly the frequency response without any consideration of the internal structure of 5 transistor OTA. Now, in the coming video, we will see the internal structure of 5 transistor OTA and how other pole and zero we should calculate, and where it is actually lying inside this GM cell, we will see in the coming video. So, it is enough for this video. Thank you.